Really, you have skills.
All right, so objective today, we got mathematical induction. Okay. There's two types of reasoning. There are two types of reasoning. There's induction and there's deduction. Let me see if I can kind of try this out real quick. Now wait for me to prompt you, okay? No, I said wait for me to prompt you. Listen. Listen, Linda, listen.
Linda, listen.
Listen, Linda, listen, listen. I'll try this again. Ready? Are you guys listening? Let's start again.
You're going up by 2.
What's next?
9.
9 what? Okay, good. Now that's kind of iffy on the induction, but here's what's happened with induction reasoning. With inductive reasoning, you're not really given a rule, you're kind of observing, and you can kind of figure out what the next step is supposed to be. Does that make sense? So that comes from within you. But if I gave you a rule, for example, I say, you know what, guys? If it's a Friday night, you catch me at Harkins watching the new release. Okay? And tomorrow happens to be Friday, right? So where will Munoz be tomorrow? He'll be at Harkins watching the new release. That is deductive reasoning. I gave you a rule that's supposed to be true, and then you made a conclusion about that. Does that make sense? So you have induction, and there's deduction. Today we're focusing on the induction piece. Okay? So, objectives today, or at the first part of this class, to understand the principles of mathematical induction and prove statements using mathematical induction. So, let S sub n be a statement involving the positive integer n if S sub 1 is true, and the truth of the statement S sub k implies the truth of the statement S sub k plus 1 for every positive integer k, then the statement S sub n is true for all positive integers n. That's your rule.
Wow.
It's written down.
Wait, every word of it?
I know, so many words.
Wait, I have a question.
What's up?
Is this our last chapter for the year? No, we have one more.
No, we have one more.
That's 2.
The next one is getting ready for calculus.
I hate calculus.
No, you don't. You've been in it.
Oh, I hate it.
Oh, well then, touche.
Touche.
Didn't hurt my feelings at all.
Just like crying in the corner.
What's that one song?
I'm trying to write down the words, but I'm not very fast.
Mine.
Mine.
One day I was just chilling. Do I care what?
Can we take an easy marathon?
Yes.
What?
Why?
No, we
Exactly
don't.
why? No.
That's the point of the
You were not doing it.
Okay. Wait, do you take an easy marathon?
No.
No.
Why do you take it?
Oh, I thought you said
No, we don't take it.
Cause like, as long as he likes to hit his, I don't know.
I always had
No, but I have your shears. Would you like to borrow my shears?
Last time I told you it busted open and flew everywhere.
I'll lend you my shears. Those are shears. Who are you? That's not how you return scissors.
Oh,
No, you can't be trusted.
okay. Okay.
I actually looked up the difference between shears and scissors. And scissors have symmetrical holes.
Yeah, that's what I was thinking. But I was like,
actual
kill it.
That's what I said too. I don't know if it works very well for left.
Well, it just better left.
Maybe it does.
They get different with
Are you lefty?
If you get like, if you're not a lefty, you can flip it. We know that she did. She did it.
Good, you know?
It gives you more power to.
Never cut towards yourself. You never cut towards yourself. I see you can't be trusted either. You're bringing out the killer right here. There we go. That's what I'm talking about.
I wanted to know what it would feel like if I did slice this little part right here.
Oh yeah, I remember that.
And my dad was like, "Why are you crying?" And I was like, "I don't know."
And you're bleeding
And I had
everywhere.
to hide it.
Okay. Here's how. There's two steps.
No, like, remember me going back to school with like.
Two steps to your inductive reasoning. Here they are. First, you want to show that S sub 1 is true. Step 2, show that if F sub k is assumed to be true, then F sub k plus 1 is also true, and the same thing for every positive integer of k. It's like how far you're going to go. Think about it as the n value before. It kind of goes hand in hand, except it's not really the n. It's like 1 before it. You know how in, oh shit, I forgot. See, I already forgot the names. The one that depends on the last one. If you have that. No, it wasn't geometric. Recursive. The recursive. I believe it's recursive. You're right. So how it depends on the last one. So k would be the last value. So if you have S sub n as a rule, then you'll have S sub k, which will be like the first kind of thing, and then S sub k plus 1 would be the next in line. S sub k plus 3 would be the or 2 would be the next line.
He's so involved in everything. Watch his part.
You're not holding your back. I heard. Was it sticky over there? Or is it eating like dry oats?
You guys good?
It's a no.
Oh wait, no, some people are still working on it.
I had a spoon and I put the spoon on the countertop. And my mom put the spoon in the spoon and I said, "No, that was my spoon." And so I got a new spoon and I started to eat. I'm talking comments. I'm just not looking. And I started to eat. And then my mom took the spoon out of my hand and
Just like those spoons with the little sugar and all the fresh juice. No.
Doesn't matter, just like your unders, but
And?
you don't.
Well, this is bad. My dad's like 5 something, like 5'8", 5'7". I'm almost taller than him. He's barely taller than me now. Since he got, how old is he? He's 17. What's he got?
Are we good now?
I just started
Okay.
over taller than me.
So let's process this real quick. Here's the rule we're being given. We've got S sub some n, and here's the pattern on that. We've got 2, then we get 4, then we get 6, then would be blah, 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 blah. They're telling us that that is equal to this formula here. Do you see it? N times n plus 1. So first thing we're going to do is we're going to try out where n, well, we're not just going to call it k for some reason. Let's do S sub 1 and see if it works. Okay? So n is 1, right? So if I put 1 in here and 1 in for n, do I get my 2 out? I do, don't I? Now we're going to rewrite this where n is not an n anymore. Now it's a k. So we're going to try to figure out if this is true. And just notice that it's the same thing, except n is not there. Now it's just a k. All right? So here's what we're generalizing. Let's try it out for the next value.
So n means it's unknown and k means it's correct.
Here's what we're assuming to be true. We're just trying to prove that this is true right now. Okay? So we're just rewriting it in terms of where it's k. So I want you right now, and work with your neighbors. Thanks for having your earbuds in and laptops open. I want you to try to figure out if you can prove this to be true for where k is 2. Okay? I'll walk around. I want you to try this out where k is 2 now. Okay? Or n is 2, however you want to think about it. Yeah, well, heads up, you should be calling it a k plus 1, correct? Technically it's 2, but we're doing where it's k plus 1. Because we're trying to make sure that this rule is working, right? For every k plus n. So first try to make yourself a formula.
Because it's right there, so you see where 2k is equal to k times k plus 1. The 2k is the actual formula of the other one, of the actual, like, sequence. And then k times, k plus 1 is You don't have a knife anymore. It's like a thing. Like a mini. I get my phone. Actually, I think we still might have like a chef. You guys know. All your good stuff.
I love green apples.
I was trying to listen to you, but then
I hear people trying to listen to me. They're like, okay. I saw him doing it too. All right.
No, please.
Did you have something? Who has something you want me to check real quick? Okay. Here's what your next line should look like.
what? No, I
Let me explain before you get crazy. Okay. What did our n's become in our formula when we had s sub k? They became k. So here's k, and we're trying to figure out what the first value was, right? K is 1, and then I had 1 plus 1, which is 2. 1 times 2 is the sum of the first part, correct?
Yeah.
Now, we're not doing that anymore. Now we're doing k plus 1, which is technically the sum of the first and the second, right? Because k sub 2 is 2. So that means that n now becomes k plus 1. And this n becomes k plus 1, and that plus 1 was already there,
Oh.
right?
Okay.
So, now this becomes, what's k? Well, k is 1, wasn't it? So I got 1 plus 1 is 2, and then 1 plus 1 plus 1 is 3. That means that the sum of the first two, aka s sub 2, would be how much? 6. Okay, want to try it out for the next one?
Hold on. You need to
Process
slow
that,
down
process
a
that.
little bit.
Wait, so K
Do that again real fast.
Do what again? The
Show
addition?
me it again, yeah.
How'd you add it?
I wasn't looking at it all the way.
Okay. Here's n times n plus 1, correct?
Yeah.
Oh, sorry. So here's the, when we did the first one where it was k, position 1, we put 1s there, correct?
Yeah.
Or we just put k's,
Yeah.
which those became 1s. And then we had 1 plus 1, which gave me 1 times 2. So the sum of the first piece is just 2, correct?
Why did you plug 1 in?
Because we tested it with this one. That's how we tested it. We tested it when s sub 1 is 1.
So you were
Now we're trying to generalize this
trying
rule.
to get it to equal 2?
Now, yeah, technically, but we don't. When we're doing just rules, we don't do 2 in there. We'll do k plus 1. Now you could do 2 if you wanted to. Look at this rule here. The original rule was this, correct? So if I just put the 2 in there, 2 times 2 plus 1, what do I get? I get 6 again. But we're testing it to make sure that the last one does work with this one that comes up here. So if I was going to check the next part, let's try the next part. It's going to be kind of gross, isn't it?
And this wasn't?
Go ahead.
This was gross.
Yeah, induction is kind of tough. Okay, well, I lost my train of thought. What was I showing you guys? What did you ask? No, there was no question? Go ahead.
We were trying to find,
We're verifying that this works for all n.
so we were replacing K with 2.
You could. Now, here is the rule in general, without having a number. It's k plus 1, correct? Which is and in the background that we know it's 2 because k was 1. So k plus 1 makes 2, correct? So if I use the original rule, we can see that that's going to be 2 times 2 plus 1, aka 2 times 3, and that equals 6, right? But we're not trying to use that. We're trying to verify this whole process that it's working for us. Okay? So what we're going to do with that rule is that instead of we can bring out this n. So here's n times n plus 1, correct? So there's the rule. We're not testing this one. We already checked and it worked, correct? We're going to check now where our sub value is k plus 1. So that means that this is k plus 1, this is k plus 1.
Oh,
Yeah?
so one,
I understand that.
oh,
And then what did k equal?
1.
K equaled 1, correct? So now I've got 1 plus 1, 1 plus 1, plus the one that was already there. I've got 2 times 3 again. So yes, it's working.
Okay.
So let's try the next one real quick. You want to try the next one? So let's see here. If we did 3, that would be k plus 2, correct?
Yeah.
Now I just want to know. So we have s sub k plus 2. We know that it's technically 3. I'm going to do it up here first. So that should be 3 times 4. That should give me 12, correct? So the sum of the first 3 should be 12, based on this formula, correct? So let's try it with the k formula. So that means I've got n times n plus 1. Now I'm checking for k plus 2, correct? Because that would be the third, the first 3 numbers, correct?
Yeah.
So what was k? K is 1. 1 plus 2 makes 3. And then 1 plus 2 makes 3. 3 plus 1 more makes 4. What is 3 times 4?
4.
How do you know that K was 1?
We verified it here, my dear. We verified it here. You start with the first one, don't you? Can k be 0? Okay, so then what's the next logical step? 1. So when we start with our base k, it's 1. How do I tell you, if I told you that k is 1, how do I tell you the next number without knowing what the number is? Without telling you what it is? I'm going to take the value of k and I'm going to add 1 to it. How would I tell you what the 5th number in the sequence would be?
K plus 5.
Well, actually k plus 4. Right? Because the first one is already that first value. This is the first, second, the third would be k plus 2. Does that make sense? Okay. Yeah, usually, because that's what we're starting with. Okay?
I got confused because when it was like a sub n, n would be 4, so then I thought we would replace k.
So here's the idea behind that. Let me go back here real quick. What's up?
Why did you plug that in for k?
We plugged in for n. Okay, so let's go back here real quick. Here's what we're doing. First, we're going to show that s sub 1 is true. I'm not even answering your question, am I? Go back. Ask me your question again before I can say this.
So, whenever you had it written down,
Yes, right here.
right there, yeah, and you, for the second one you had k plus 2. You k plus 2 bracket with k plus 2 again. Why?
Because we were testing k plus 2. We were testing. We went above and beyond a little bit, and we were just checking to see if this was going to work. So we were going to test k plus 2. Technically, that is this, correct? Okay, so I'm going to just check first so that I know that when I get there, I have the correct thing. So this is 3 times 3 plus 1, correct? Which is going to give me 3 times 4, aka 12. That's just something to shoot for. So I'm going to test what we are assuming to be true based off of the S sub n rule, correct? So here we go. So now I don't have k because that was for k. And we don't have k plus 1 because that was for the next one in the sequence. Now we're going to test k plus 2. So here's k plus 2, right? Okay, so this guy became this guy. And before it became this guy. And now it becomes k plus 2. If I was going to check the next one, it would become a k plus 3. K doesn't stop being 1 because that was the first thing ever. And all I'm doing is checking to see if the rule continues to work.
So basically, if it's k plus 4, it's going to be in that kind of formula. It's going to be k plus 1 times k plus 4 plus 1.
Right. And it's just so that we can try to figure out, hey, you know what, if I wanted to know the sum of this in the first 15 of them or something, then I can do that using this formula because I've already verified that it's true. Okay? All right. Yeah. Exactly. The sum of the first 5. These are the sums. Remember what we got for the first one? The first one we got 2, correct? That's this guy. The next one we got here, this was equal to 6. That's the sum of the next 2. And then for the next one, we got 12. Remember the one we just did? Well, that's the sum of the next 3. So if I want to do the sum of the next 4, then I would be doing s sub k plus 3. Okay? Induction is kind of like inception. It's going to mess with your mind. Deduction is like, you gave me the rules, I know what they are. Okay? Alright, so, yeah, we did that already, boom, moved on. Okay, try this out. Try this out. For this given statement, I want you to write out the next 3 statements for s sub 1. So you want to do s sub 1, s sub k plus 1.
Oh, that was so bad. I was
We're just trying to find the first what it looked like. That's the rule right there. See how all that is? That's the rule. So the first thing we're going to do is that means that every n is 1. So write it with every n. 1 squared plus 1 plus 1. Yes.
At some point.
Yeah, so it looks weird, but that's all it is, and you don't even do anything else. We're rewriting it. Yeah, these things. Now, for the next one, we want you to write K plus 1 parentheses.
On the day 9, I took a plane out.
Wait, is that a 16? Oh, it's a 54. Yeah, 90 plus 2.
I was gonna say something to Harvey earlier. I don't remember what it was.
I'll be right there.
So the 9 times 3 is 37.
What's that? Plus 1 is funny. That's all you gotta make sure. Good job. Yeah, on that point. Don't go any further than that because that's just too much. What's up? Perfect. You don't have to plug anything in. This is all.
It's all just one of those.
Okay? Well. Are you good? Alright, here's the forms. First one, all we're doing is plugging into 1. Ooh, what I got dizzy.
Yeah, I
You're
just
getting
realized
dizzy for
something in
different
there.
reasons.
So S sub 1, your 1s are becoming that 1 plus 1, quantity squared over 4. Looks like it does simplify out to be what, 1 cubed? Okay. Here's one where it's K now. K squared, K plus 1 squared over 4. Does work, right?
Yeah.
And then we got K plus 1. So now my K's are becoming K plus 1. I've got K plus 1 again here. Yeah, you can go ahead and take that 1 plus 1 and make it a square. Oh, there it is, the 2. And there you are.
Really awesome.
And then when you're checking the rest of them, do you use that formula? Or which formula do you use?
Well, you should have already verified it here, which
Yeah,
means that
but
this is true.
if you're plugging in a value, like if you're plugging in a 2, which formula do you use?
You use
The K plus 2 version.
Yeah.
But all we're really doing is verifying that this is true. This should work always.
I know, okay. It's just like, so I know how to find all the formulas now, but then I know it's gonna ask you to like find a value.
Yeah. Well, just remember that if it's like the 5th, then it'll be a K plus 4. It's always 1 less because you're always depending on K, and K is 1. So whatever you add to K will be 1 less than the number you're looking for. So if they're saying, hey, what's the sum of the first 5 or whatever, or the 5th one in this case, then it would be a K plus 4.
I'm running like, if I want to know the value of 15, I do K plus 14 squared K plus 15 squared.
What did this clean up to? What did this clean up to? If this was a 2, this would be 3 squared, right? And this would be a 2 plus 2, 4 squared? Over 4? So this would be 7 squared over 2 squared, which would be 5 squared.
How'd you get 3 from
No,
the
you
K
can't do
plus
that because it's
1?
not the same base.
Oh, because it has to be a,
Not the same base. Yeah. Never mind. I was trying to figure something out. Okay, You guys good?
Yeah.
So, if you can find S sub 1, S sub k plus 1 right now, you're good. You're good so far. You're finding what? The actual value? That's k plus 1. And you're good. Okay? Alright. Proving formulas are true by mathematical induction. What's our first step?
We're gonna show that.
Prove that S sub 1 is true. So here's our first part. Is this true? Yeah, because 2 equals 2. Then? No, then show that S sub k is true. And because that's true, then that means that S sub k plus 1 should be true as well, okay? So here's our formula. What?
2k plus 2k plus
What?
This is the math that we were doing. Yeah, we would just be checking those again. We already did that though, didn't we? Okay, so I kind of skipped ahead. My bad. My bad. Oh, yeah, we're done.
Yes, we were left today.
Haha, you're funny.
That took a whole hour to go to the side.
Yeah, I think it was the first part's kind of weird. But it's not a whole
I
hour.
actually understood something.
Was it a whole hour?
And in here it says 10, it's 10:50.
Yeah.
Wow.
We wasted
9 slides took a whole hour?
It's because we spent a lot of time explaining it.
Alright, that's true. But you know what? It was easier when we got the other part done. Alright, let's get rid of this guy.
Are you just gonna keep the live going?
Yeah, we're just going to pause for a minute. Because if I stop it, then it has to load and it won't let me make a new one until it's loaded. So I'll just pause. I'll bring this guy up.
10.5.
Then it's not true. Yeah.
Wait, can we do some Zumba or something?
Show us pizza. Oh, great one.
Everybody's kicking me. I'm scared.
The binomial theorem. The binomial. Hey, you teach this one. No?
Thank you. Alright. Wish I could.
It's from stats. Binomial theorem.
Is this
The binomial theorem.
Oh.
This is fun. No, it's not. It's not.
Yeah, it is.
It's not.
Binomial's the worst.
Have you ever watched that movie?
Binomials are fun.
The student stole a teacher's Munoz, have you ever watched that movie Drop Dead Fred?
Oh, my niece has. There's lots of those, aren't there? So never mind.
Who stole it? Who stole it?
I can't do that at first.
Oh, I took a video of it. No, they're playing. There's a video back on the screen. Just goes big.
There you go.
Boy said it was cool. And they got caught by security.
Hey, this is a binomial theorem. It's got the coefficient.
They're playing games.
Didn't I spend the money at that little library store?
I'm already done with the review. Heck. I already done like in 10 minutes.
You know what? I'm actually a little sad.
Wait, what? We haven't had movie. We said we had
Melissa,
Tuesday.
was it Miss Celeste?
Yeah.
Oh, I hate her.
Go, 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 go. Click,
You said there was a
click,
test
click,
next Tuesday?
click. Yeah.
Oh, tomorrow. Is it tomorrow?
Remember
Wait, tomorrow?
Chapter.
Tomorrow, because I think you said, oh, don't stress.
Chapter
it's
6,
not-
right?
No, because on Tuesday we have the SAT. It's yesterday.
They're throwing out.
Yesterday when you asked me, you said you didn't want to do it tomorrow because you said, don't stress over it. We'll do it
I don't want
next
you to
week."
stress. We were going to do it next week, but. Yeah. But then next week is also math week, isn't it?
But I can't handle
Monday
it.
Monday,
I'm not
Tuesday,
done with the
Thursday.
review.
I'm not anywhere.
I guess you just looked over there.
Okay. I thought we were going to do some stats right now. I was all excited. It's not stats. All right, let's get started here. Hope you guys got some time to breathe.
Oh, this is the
Still
best
live?
test
So there is a test.
No, I'll figure out. I don't want you to stress on it right now. Okay, so we need to figure this out then. Tuesday we're testing math things, aren't we? Or easy merit, I mean?
Yeah.
That's
I thought you just
No,
said
We don't
Thursday.
You guys aren't.
It'd be Thursday.
Oh, so then then we're fine. We'll test Tuesday.
Okay.
You'll have a whole lot
Alright.
of block to do it in.
No.
Oh no, I don't see you till Thursday.
No.
You don't see us, well, it's different tomorrow.
We have the SAT on Thursday.
Hold on. Okay, stop, slow down, slow your roll. So next week we have to test. What do we want to do it on Monday? We can't do it Tuesday because I don't see what I see for 30 minutes or something.
Monday, we can't do it.
We have another block day.
1 and 3.
We have another block.
Monday? What do you mean Monday's 1 and 3?
They changed it. It's different.
Monday, 1 and 3.
I want to do another block day.
Just 1 and
Next
3?
block schedule
Yeah.
are Monday and Tuesday.
Oh, yeah, sorry. I'm 1 and 3.
So this week it was Tuesday and Thursday. Next week is Monday and Tuesday.
So next week is Monday and Tuesday?
Wednesday, you can take it on Friday next week.
Okay, so what do you guys want to do now?
Can we do it on Friday next week? Because Tuesday will be the SAT, and then Monday and Thursday it's 1 through 5. So then next time we see you next week is
So we're pushing the test for Friday. You guys gonna be ready?
Yeah.
Wait, which Friday?
Friday.
Next Friday.
No. Next week Friday.
When you have 6?
What?
Chapter 6?
It'll be chapter 6, I believe.
Okay.
Okay. Thank you very mucho.
Next Friday.
Thank you very mucho. Here we go, binomial theorem. Let's go get started here. We're going to evaluate binomial coefficients. The binomial coefficient, do you guys remember doing combinations, permutations?
Yes. Maybe that.
Do you guys remember combination permutations?
Yeah.
The binomial coefficient is a fancy name for combinations.
Oh, cool.
Kind of, but that's not how we write it in the stats. Okay? So here's what you guys have seen. Something like I've got 5, choose 3 kind of thing. Okay? The binomial coefficient, the way we write it instead, would be 5, choose 3. Okay?
Oh.
Just an FYI, between you and I, they're the same thing.
That rhymes.
You do them the same way. Okay? But they're just written differently. Okay? In stats, this is how we do it. And when we're doing probabilities, combinations, or counting principle type stuff, we usually do it this way with the 5 choose 3, 5C3, okay? But this right here, my friends, is the binomial coefficient. What that does for me is simply tell me all of the different possible ways that I can choose a specific number of items. Okay? That make sense?
Yes.
Okay. Once we do the math, I'll give you the formula. Okay? So, let's get to it. Here's the formula for that. The formula is n factorial over r factorial times n minus r factorial. Okay?
This was
Yeah.
my favorite thing ever. Oh goodness.
I can't focus. I don't know why.
Because you just did your lesson and now we're doing another
No,
one.
it's been all day.
Well, I just got dizzy a couple times.
Oh my god. Oh my god.
Probably like
I have to start this is like braiding. That's what I started doing.
oh my
Oh my
god.
goodness.
Actually, no.
I'd rather not do that with it.
Just an FYI, for this, the combinations, the order doesn't matter. So if you're counting things and you chose, you're making a shake for some reason and you want to do strawberry banana, in the world of combinations, strawberry banana and banana strawberries are the same thing. It doesn't care.
Oh, really?
Yeah.
Right. That's what's important. And you'll usually tell the difference because see how this has an extra r factorial in there?
Yeah.
That's the difference between a combination and permutation. You drop that r factorial, now you're working with permutations where the order does matter.
Are we doing those two?
No.
Oh.
No, 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 no. Okay?
so.
So they're both counting principles, correct? But in a combination, the order in which you choose things doesn't matter to it. Okay? So here's what I need. For everybody, the question was, what is the difference between combination and permutation? Here's what I'm saying. I need to make a committee, okay? So here's I'm going to make a leadership committee. Does that make sense? So here's combinations. I need a leadership committee. I choose person 1, 3, and 5. I could have chose this person first, second, or third, or I could have chose this person first, second, or third. It doesn't matter at the end because they all have an equal say. Does that make sense?
Yeah.
So they're just the leadership committee. It doesn't matter if I pick them, they got picked, they're there. So for combinations, here's what we have. Now, if I was going to choose leadership, but I was going to first select president, then vice president, then treasurer, or whatever the order is, then that order would matter, wouldn't it? I would care because whoever got picked first would be president, right? So this would be a permutation type thing, where the order does matter in how I pick him. So here, if I picked 1 and then 2 for vice president, that would be different from picking person number 2 for president versus person number 1 for vice president. Those are two different counts. And then I would go, let's see here, I would go 3, and then here I would go 3, right? So, let's see here, what am I doing? I kind of lost count. I could have picked them 3, 2, 1. In a permutation, all these would matter. They would all be different counts. But in a combination, they would all be the same thing. It would just be one way of doing it. Does that make sense? So you can see how many different ways I can change these, right? I can alter them because the order matters. But over here, you got 1, 2, and 3. It's all the same thing. So here, the way I think about it here is like milkshakes. It doesn't matter how I pick it. They're all going to be in there at the end, and they're all make my smoothie. And over here, I really do think of like if I was going to pick these, right? What my main dish is, what my side dish is. All right, cool.
It's getting cold.
So 6, choose 3. How many ways can I have 6 items and choose 3 of them? Well, I can use my formula. I've got, what's my formula? N, right? Over r factorial, 6 minus 3 factorial. So I've got 6 factorial, 3 factorial, 3 factorial, correct? Yes, we can use your calculator, but you want to be able to know how to do it by hand too. So here's what I'm going to do. That means that we've got 6, 5, 4, 3, 2, 1 over 3 times 2 times 1 times 3 times 2 times 1. Because I've got 3, 2, 1 here, these can actually, I hate saying cancel, because they make ones. But yeah, I know what you mean. And then I can start doing some division here. 3 goes in here twice, 2 goes in here twice. So I've got 2 times 2 is 4, 4 times 5 is 20. This whole thing is just 20.
You could have made that a little easier and just did the 3 and 2 and then maybe.
It's totally up to you how you want to do it. Whatever you see is just fine. Now if you want to use the calculator, then go for it. It's going to be under math, probabilities, I think. And then you're going to go NCR. NCR. Here, I'll show you. Let's do it on the calculator real quick. Let's clear this. So I'm going to go into math, probability. Option number 3 is my N choose. I had 6 items, and I'm going to choose 3 of them at a time. And I can only do that 20 different ways. Math, probability, NCR. Okay?
Oh, I remember that.
Cool. Here's a fun one for you, Lexus.
I just wanted to yawn.
I've got 6 items. How many different ways can I choose 0 of them?
One way.
It's not different. If I have 6 items, how many ways can I choose none of them? Only one way. So 6 choose 0 is just 1. What happened?
You interrupted my yawn and I didn't finish.
I'm sorry. Now you feel like you have to yawn. I need my other half. So there is that.
I've had this game since.
You guys good? Okay. Look at this. Tara, how many ways can I have 3 items and choose 3 of them? I think, yeah. Does that make sense? There's 3 things. I got to pick 3 of them. There's only one way. There's only one way. 9? It used to be. What about 8 choose 2?
Hang on. 7. That would be 8 times 7, 56.
We would be doing 8 times 7 times. Okay. Huh? 8 choose 2?
Sorry, I thought it was smart.
I don't know. I made just
Wait, if you have 3
No, there's a lot. Because if you think about it, you've got 8 ingredients.
What?
And you're picking 2 of them at a time.
Oh.
That's a lot. Oh, more than that.
1, 2, 64.
Because I can do ingredient 1 with ingredient 2, 3, 4, 5, 6, 7, or 8.
And then 2,
And then I can do
1,
2.
3.
What? You
Right.
can cancel a lot.
There's a bunch of different ways I can do that. Huh?
It's not 16.
I'm gonna just do the.
Do what your formula. So it should be 8 factorial, 2 factorial times 6 factorial. So 8 times 7 over 2. What's 4 times 7? Ah, you see what I did there? No? Okay. What's 6 factorial?
Oh!
6, 5, 4, 3, 2, 1, right? So why write them again? So I just go 8, 7, because 6, 5, 4, 3, 2, 1 will cancel with 6, 5, 4, 3, 2, 1. And then I just put in the 2 factorial. I don't put the 1 because do I need to multiply by 1? Make sense?
I knew it.
Unless I have a calculator. For example, here. You see why I just did 8 times 7, correct? Good. And the 2 factorial is 2 times 1. I don't need the 1. Because I don't need to divide by 1. And then I did 8 divided by 2 is 4. 4 times 7 is 28. Okay? I did with the same factorial. Yeah, 4 factorial and 4 factorial. What would that become? Technically, 2 factorial or cancel out 2, 1. You would have 4. Okay, I want to show you a couple things. This what we're doing is called now binomial expansion. Binomial expansion, and I'm going to show you because I like understanding. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. You guys recognize this thing? 1, 6, 15, 20.
Oh, alright.
Are you just adding them?
Yeah.
Oh.
6, alright. 1.
Yeah. You guys recognize this thing?
Yeah.
Okay.
I see.
I hate this.
Whoa.
I look like a triangle.
I like it. It's great.
Meow.
Thank you, Alyssa. Alyssa's texting.
What's your point of doing?
Sorry. I kind of lost it a little bit. I'll try to make a connection here real quick. Can someone do? Can someone do on their calculator real quick? 4 choose 3, and tell me if the answer is 3.
No, I don't like these things.
What is this? Anybody know this guy?
Pascal's triangle.
This is called Pascal's triangle, right? Was that right? Oh.
It's 4.
Oh, so close.
What's 4? 4 choose 3 is 4?
Yeah. You see, right?
Yeah.
Want me to see the calculator?
No. Okay, try.
He never added me back.
You're not a real nigga.
Only knows that I
Cold.
Tell me if 5 choose 2 is 10.
Yes.
It is? What about 5? Tell me if 5 choose 3 is also 10.
5 choose 3.
Is also 10?
It is 10.
It's also 10? Woo! Okay. So,
Show us how.
all right. So, I'm trying to show you guys where this stuff comes from, okay? Which is really, really trippy and really cool. Here is Pascal's triangle. Everyone understand Pascal's triangle?
Yes,
Okay. Mathematicians are amazing, and they came up with this thing for binomial expansion. Okay. I want you to think about Pascal's triangle. See if I can do this. This is going to be some binomial. We'll go x plus y to the 0 power. Question: what is anything to the 0 power? It's 1. Do you see the solution up there? It's just 1. Okay? Now, if I had, let's say I actually did have x plus y to the first power, what would that become? It does become x plus y, right? X plus y. What are the coefficients on x plus y? 1 and 1. Look at the coefficients here. If I did x plus y to the second, x plus y to the second, let's do that real quick. X plus y to the second, what would that become? Once I factored it out, this would become x plus 2xy plus, sorry, it would become this, wouldn't it?
Yeah.
Look at the coefficients on this. 1, 2, 1. Coefficients?
1, 2, 1.
So if I was going to do something to the third power, guess what my coefficients would be? 1, 3, and 1. Does that make sense? Okay, cool. So I could actually use Pascal's triangle for some binomial expansion. Let's try something real quick, and then I'll show you what the patterns are going to look like. So I want to do some. Let me get into a smart. Let me get into something smart real quick here. How are we on time?
Very good.
11:15.
Okay. Because I really want you to understand this is where it's coming from. I want to copy my triangle. It went away. Anyways, we can make it up again. Thank you. I want you to pick a binomial that we're going to multiply out, okay? And then we're going to use Pascal's for this, okay?
7, 3. 7. I love to.
Let's do something kind of fancy, like
23.
2x, what?
Plus 2/3.
Plus what? No, don't.
7.
7 sounds good to me. Now, What degree do you want to take this to? To the 4th degree?
Yes.
Sounds good to me. So, can you imagine the tediousness of having to do this problem? Because I think everybody would go, oh, correct me if I'm wrong. How many people would go 2x plus 7 times 2x plus 7, and then do 2x plus 7 times 2x plus 7, and then take those two and then multiply them out?
Yes.
Right?
Yeah.
That's not the objective here. We want to be able to go straight to what we're supposed to do, or straight to the answer, right? That would be the nicest thing to do. Okay. So, who remembers the Pascal coefficients?
1, 3, 1.
It was 1,
1, 4, 6, 4,
1, 4, 6, 4, 1.
Yeah.
That's yes.
To the 4th power.
Torres. Is that correct?
For the 4th power?
For the 4th.
Yeah.
So we went down.
Wait,
0, 1, 2, 3,
hang on,
4.
I might be
Yeah.
stupid.
1, 4, 6, 4, 1.
Hang on.
1. Yeah. Good.
Is that the 3?
Thank you.
Hang on, I might be stupid.
No, I just checked it. It was correct. Everyone okay with where those coefficients came from?
Yes.
Okay. Now, I want to show you the pattern that always happens here. When we have an x, like remember the when we expanded x plus y squared, it became x squared, correct?
Yeah.
And then we had plus 2xy plus y squared.
Yes.
Notice what happens to x. 2 is the highest degree, correct?
Yeah.
And then it dropped the degree down to 1.
Yeah.
And then it went down to 0. And then the y
That's
went the other way, didn't it?
Yeah.
It went from 0 y's
yeah.
to 1 y to 2 y's. This was when I squared it. So if I was going to do a cube, guess what I would start on my x value?
3.
I would start with an x to the 3rd. How many y's?
You'll have to.
None of them. It would be a 0.
Oh, right there.
So
I was like, what?
then I would have
X squared.
some other coefficient. I don't know. I'm going to leave these as question marks, okay?
X squared
But what would happen to my x?
It'd go down.
It would drop 1, and y would
Go up.
go up 1, so it'd be y to the 1st, right?
Yeah.
I don't really need to write it, but I will. Then on the next one, I have some coefficient. X to the
First.
1st, y to the 2nd. Then I would have some coefficient again. X to the 0, y to the...
Third.
Does everyone see the pattern that's happening here over and over and over and over?
Oh.
Good. Good.
Is it 1, 4, 6, 4, 1?
So that's what we're going to do. So on the next part, that means we would have, and we know the coefficients thanks to Lily here. The coefficient would be 1 because we're doing the 4th power, right? What would my x be?
Four.
X to the 4th plus 4, x to the 3rd, y to the 1st plus, what's my next coefficient? 6. X to the 2nd, y to the 2nd plus 4 x y to the 3rd plus 1 y to the 4th, right?
I like that. That's actually a lot easier.
Yes?
I didn't know
Okay.
Pascal's triangle was so useful.
Here's what I want to
Remember last year? This is terrible.
so everyone's okay with this so far?
Yeah.
I want you to kind of in your mind convert those x's and y's to the first item and the second item. Convert those x's to being the first term and those y's to being the second term. Does that make sense?
Yeah.
Okay? And then what we do is we plug them in and then we simplify it. So, here's what it should look like. I'm going to erase this. Are you guys cool with that? So, 1, x to the 3rd, right?
4.
Oh, 4th, sorry, thank you. And that first item is 2x.
Yes.
So what's this going to become? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16?
Yes.
Is it 16 then? So 16 x to the 4th times 1 is 16x to the 4th. There's our first term in our expansion. Next one, 4 times x to the 3rd, we multiplied by 1. But anything times 1 is itself, isn't it? There's no y's.
Oh, yeah.
It's y to the 0, which would be another 1, wouldn't it?
But it's, I thought one is the second term is one.
Yeah, but there is no second term here.
Remember, because y is 0 in the beginning.
Okay? On the next one, we're going to get something now. So this becomes 2x. This becomes a 7. Right?
Where's the y?
Right here.
That is the y.
Yeah, but
Y is the second term in here.
So why does x have an x in it and y doesn't have a y?
Say that again? Oh, because that's kind of just the way they worked out. We can have a y there. It just depends on the problem. I used x's and y's just so that you can see the pattern.
Just variable.
And you can make sense out of it. Okay? All right, so I've got 2 times 2 is 4, 4 times 2 is 8. 8 times 4 is 32. 32 times 7 is... That's what it is. 32 times 7.
224.
One more time.
224.
224. X to the third. Let's go to the next term. We're going to have a 6. X to the second. Y to the second. 7. And 2x, right? So now we have... I'm going to use a calculator. This is getting
Yeah,
crazy.
just use the calculator. I can do math in my head, but I don't want to.
Second quit. I'm taking 4 times 6 times 49, right? 4 times 6 times 49? 4 times 6 times 49? I've got 1,176 x to the second. Yeah?
Yeah.
Please let me know if I've lost you anywhere.
You're welcome.
Where I found you. You're in front. You're okay with how I got these numbers? What's 2 to the third? 8 times 4?
32.
32 times 7 is 224. And then x cubed is just x cubed. Okay? Let's go to the next term. Next term. Where am I at? 4? So I've got 4, x, y. What's this? It's going to be a 1 now. This will be a 3. So this will be 2x and this will be 7. So I've got 7 to the third times 4 times 2. What's up? Yeah, I should have done it at the top. This should have been here. And this is going to become 2744x. Right? And then finally the last number, I can't fit it here. It'll be plus 7 to the fourth, won't it? Yep, plus 2401. So there we go. There is 2x plus 7 to the fourth, expanded, and we did it on 1 page and not 3.
Yeah, but
And if you look at those in descending order, it's supposed to rearrange it.
They are 4, 3, 2, 1, none.
Yep.
Nice.
Well, shouldn't it go like that anyways? Because that's kind
I
of
don't
how
know.
it goes.
There's no significance to that. No significance. That was a lot. Questions?
No, actually, I understood.
So I set that up because here's the formula they give you, and you'll see it in the book, and I don't want it to scare you. Boom.
Ah.
I remember that.
Okay? Oh, go back. That's the formula they give you. No, it's what we just did. Notice how they do n choose 0, n choose 1, n choose 2, n choose 3, n choose 4. Okay? I want to go back. So, hold on. You should write this down and take a picture.
I don't want to do that.
You should write this down and take a picture. Put it in my airdrop.
My camera won't Dude, I gotta call my mom.
Wait, what's the
Oh, no, you heard.
Oh, dang, that was almost perfect. You go a little bit further. Are you kidding?
Okay, looks like we're good here. Let me go. Oh, yay. Where'd it go? Oh, okay, no. Here we go. Here we go. Here we go. So let me go back to this guy and what I was kind of confirming with Catherine. And what you saw on your formula. Okay? You guys remember how every single one said n choose 0, n choose 1, n choose 2, n choose 3? Okay. And I said, all right, so someone give me some combination, please.
1,
Maybe
5, choose 4.
8 choose 2.
12.
How about 3 choose? No, not 3 choose 3.
Oh, 4
Let's,
and 4.
4 choose 4? Well, that's only one.
4, choose 2.
Let's do 4 choose 2, okay? You guys remember how I did the? You guys remember how I did the degrees? It was 0, 1, 2, 3, 4. So let's get to 4. 0, 1, 2, 3, 4 is right here, correct?
Alright.
Now I'm choosing 2. 0, 1, 2. So that means 4 choose 2 is 6. So all they're doing with that n choose 0 is they're saying, oh, n choose 0, choose 1, choose 2, choose 3, choose 4. They're having you find these numbers that are already in the Pascal's triangle. Does that make sense? Okay.
What if you have like 17 choose like 16?
So that's a fantastic question. I'm making connections here for you guys. If you're going to be doing like 17, choose something, I'm not doing Pascal's triangle that far. I'm using my calculator. So if you want to use your calculator for that, that's okay to get all the coefficients. But it's important to know that usually when you have some degrees, you're going to get one more on the coefficients. So 0 means you got 1 coefficient. If you did the first degree, you got 2 coefficients. The second degree, you had 3 coefficients. The fourth degree, you had 5 coefficients. 6th degree, that means you're going to get 7 coefficients and so forth and so forth, okay? So that's just one nice way of checking that you have the right number of terms inside of there, okay? All right, question time. Anything I've said? That was a lot. Cool, then let's move on.
It's been like 15 minutes.
So see how they're doing that? They're just grabbing the numbers here from Pascal's. A is increasing by 1. And B is increasing by 1. 1, 2, 3, and so forth, so forth. Okay? I think that's it. Okay. Write this formula down. Finding a particular term in a binomial expansion. Finding a particular term in, so let's say you were doing what problem did we do? 2x plus 7? Let's say you were expanding 2x plus 7 to the 4th, and you just wanted the third term. This would get you there. This would get you there.
Would it get me?
Yes, it would.
Is this 4.5 still? I have a 91.6.
This is 10.5.
Okay.
Wait, so can I run it to what 90?
You're gonna fall on the chair.
That's good?
No.
No?
We all sing, and then after the bell rings one more time, we go. Yeah.
Yesterday I was playing on my beer, and I ended up with a couple of whiskers in my hand. I don't want to though.
Okay.
Good? Okay. Here's the idea. I'm supposed to expand this, and they want the fifth term. How many terms does this thing have?
9. Jesus.
2.
Oh, 2, sorry.
It has 10. It has 10 of them.
How do you know that?
Because it's always one more than the degree. That's what I was saying a minute ago with the Pascal
I
fragment.
heard you, but
I didn't process it.
no.
So, what's the formula? It's n choose r, right?
Yeah.
Times
A to the n minus r, b to the r.
Yeah.
Okay. So you can kind of see what's going to happen here, right? My first term here is a 2x. My second term is y. So there's my first, there's my second. So I've got 9 choose what?
5.
What is 9 choose 5? You can do that on your calculator.
Wait, how do you do that again?
Math, probably.
Oh,
I got
Wait, what am I plugging in?
I got one.
9 choose 5.
I got 126.
126? This should be the 5th power. This should be the 4th. So, 2 to the 4th, is that 16? That's 16, right? So what's 16 times 126?
How come you made the y here?
A 4?
How'd you know it's a 5 and a 4?
Well, what is R?
A 5.
9 choose 5, right? So there's 5.
Oh, okay.
And both of these should always add up to this.
I mean, I want to write this down. Okay, just keep going and I'll write it.
What'd you get? Who got me the number? 126 times, what did we say, was 16? What is it? Okay, I'll do it.
Wait, what?
I say 2016.
No, I don't want to guess.
I'm saying it's around there.
2016.
Oh!
And there, my friends. What did I hit?
I somehow got like 8,000.
Oh, wait a minute. That's not right. That's not right. If it's the 5th term, this should be 4 now. Right? Because remember it goes 0, 1, 2, 3, 4.
Oh.
Ah! So this should be 4. This should be 5. They gotta add up to 9 still though.
What?
They still have to add up to 9.
That'd be 32.
What is it?
Some big number.
11.
I don't even have it on me.
Thanks, Captain Obvious.
It's probably like
2 to the 5th
4,032.
Yeah,
times.
4,000.
No, I'm depending on me now. You had your shot.
You just said R was 5.
I forgot to count 0.
Double what it was.
Remember how they go? They start. It starts with the highest, x to the 9th, y to the 0. And then it was, the next one would be x to the 8th, y. Then it would be x to the 7th. It's one less. And I forgot about that right now. In my question.
Y n minus R. So if 9 minus 5 was 4, why do you have 5 there? Is it a 3?
It should. So then r should be 4, right? So this is wrong too.
Should be 5.
Ah!
Go look at your notes.
I'm starting again!
No!
What didn't work? I think we all need a break.
You guys were not the sweetest kid.
Yes, it is 4. Remember, r plus 1 term. We're looking for r. So if we're looking for the 5th term, then r is 4.
Okay.
So you were right.
Yes. But I didn't make that change.
Abracadabra.
I made the change over here, but I didn't make the change over here. So I'm doing the 5th, choose 4, 2x to the something. I'll do that right now. Y to the 4, so this should be, sorry, not 4, 5. Okay, so what's 9 choose 4?
9 choose 4.
9 choose 4.
I still got 126.
That makes sense because it's in the middle.
Yeah, okay.
So, what's 2 to the 5th?
2 to the 5th is
32? We'll get it. 9.
Save $1.
Let me check this. Yes. Hot, let's do. There. Okay.
Wait, why is it 9?
Oh, that's what I got.
Because remember how it starts with 0?
Yeah.
So to get to the 5th term, you'd have 0, 1, 2, 3, 4. My highest x would be 9, right? It would be y to the 0. Then we go 8, 7, 6. And then this would go y is 1, 2, 3, 4. First term, second term, third term, fourth term, 5th term. 4. That's my R right here.
Alright, I got another question. Did you just do 126 times 32?
Yeah.
To
Yeah.
disperse the 126?
Here's the rule right there. If it's the R plus 1 term, R plus 1 should be 5, right? It's the 5th term. Then I'm going to solve this, which means R is equal to 4. And then we just plug stuff in there.
Is it the same if we do 126 times y to the 4th and then have the x?
Yeah, 126 times y to the 4th times this one. It's multiplications for me to do. Doesn't matter how you multiply this. Yes.
Oh my goodness, I got some ceviche last night because I really wanted to. I lost.
Done.